Hey guys, welcome to another Miss Freeze video. Whoop, whoop. So today we're going to talk about inertia. And what's this? Inertia. Now you guys have probably heard of inertia thanks to Bill Nye, because at some point he goes, inertia is a property of matter, in the introductory video that you all know and love and sing every single time. But it goes way beyond a property of matter. It's actually a law of motion, and you guys have been experiencing inertia your entire lives. You just don't know you've been doing it. So let's dive in. Inertia basically says that objects that are in motion will stay in motion, and objects that are still will remain still, or the fancy science term is at rest, until something makes them move or change or do anything different. Perfect example of balanced versus unbalanced forces that we just learned about. So what you're looking at here is a car crash video. Not a real one, a fake one. It's no big deal. What you're going to see is the crash test dummies. Now, in the far side of the car, you'll see that both crash test dummies are seat belted properly. In the front side of the car, they're not. What's going to happen? Dun, dun, dun. Now, if that were me, even though it wasn't pleasant for anybody in the car, I would much prefer to be one of the two seatbelted people in that vehicle, for the simple reason that I didn't go through the windshield. So what happened? What happened here is that inertia happened. Objects that were in motion, which was all four objects, in this case people, in the car, but it does apply to, say, your groceries, your apples, whatever. All four people in the car were moving at the same speed as the car. So let's say the car is moving at 35 miles an hour. All the people in the car are moving at 35 miles an hour. The car smacks to a stop. All the people inside the car are still moving at 35 miles an hour. What's going to stop them? The seatbelt, the window, each other. That's the inertia of it all. But aren't we safe in the back seat? I mean, if the person in front is buckled, it's cool. The seat's going to stop me, right? I mean, I'm perfectly safe back here. If I'm in an Uber, I never need to buckle, right? No, you're more likely to die in the back than the front. In this scenario, we have a belted front seat and an unbelted back seat. You can see the seatbelt and the airbag will stop the front guy, but the back guy just keeps going and going and going. Okay, that was a little heavy. I understand. So inertia also applies to things that aren't just car accidents or car crashes or anything that could go bump in the night. Sometimes it's about not being able to stop. So we're going to watch a video where friction has been reduced. So if you forgot what friction is the force that slows or stops motion. So when you reduce friction, or when you take away that ability to stop motion, things just keep going and going and going and going and, well, going. So here we have an egg sitting on top of a toilet paper roll, on top of a pie plate, on top of some water. Inertia at its best. Object not moving, object's not going to move, and then boom, the egg stayed where it was, and because they took off the support, gravity made it fall down right into the water. Okay, so let's have just a moment before we begin our next video. You guys know I hate those challenges. They're dangerous, they're silly, people do ridiculous things, but there's always an exception to a rule. I have found one that I actually think is hilarious, and it perfectly follows inertia. The whipped cream challenge. Take a look.